straight line parallel to one side of a triangle cuts the other two sides proportionally. Specifically, if DE intersects AC at D, BC at E, and is parallel to side AB of triangle ABC, then CD divided by DA equals CE divided by EB. We're going to use the elegant method by Euclid to prove this. We'll first prove sufficiency from parallel to proportionality. Then we'll prove the inverse, necessity, from proportionality to parallel. First, we'll show triangles ADE and BDE have equal area. Since DE is perpendicular to AB, it means point A and point B are of the same distance from DE. So, if we draw AH perpendicular to DE at H, BI perpendicular to DE at I, the length of AH must be equal to the length of BI. DE is the common base of the two triangles. Therefore, the two triangles have the same height and same base length. Their areas must be equal. Next, we'll look at triangle CDE and compare its area to triangles ADE and BDE respectively. The two ratios are equal because ADE and BDE have equal area. If we draw EJ perpendicular to CD and DK perpendicular to EC, we can express the area of CDE as half EJ times CD, or equivalently half DK times CE. Triangle ADE's area is 1/2 EJ times DA, and BDE's area is 1/2 DK times EB. After cancelling out the common items, we get exactly CD divided by DA equals CE divided by EB. And that concludes the proof for sufficiency. To prove necessity, we just need to inverse the process. If CD divided by DA equals CE divided by EB, then triangles ADE and BDE must have equal area. Since DE is the common base, point A and point B must be of the same distance from DE. Therefore, DE is parallel to AB. Now, how about an example? If DE is parallel to AB, EF is parallel to AD, CD divided by DA equals 1/2, and the area of ADEF equals 24. What is the area of triangle CDE? If we draw CG perpendicular to AB and CG intersects DEH, then CH must also be perpendicular to DE because DE is parallel to AB. Also, CH divided by HG equals 1/2 based on what we just proved. So, the height of triangle CDE-CH is half the height of the parallelogram ADEF. The area of ADEF equals its height, HG, times its base, DE, while the area of triangle CDE equals half of its height, CH, multiplied by its base, DE. Replacing CH with half HG, we get the area of triangle CDE equals a quarter of the area of ADEF, or 6. And that is the answer. If you enjoy the content, please like, subscribe, and comment. Now go enjoy your life.